Imagine a circle. Now, let's divide this circle into thin, ring-like sections, known as annular regions. Picture each of these rings carefully cut and then straightened out to form a rectangle. As we move outward from the center, each ring's radius increases, and so does the size of its corresponding rectangle. Now, let's organize these rectangles by stacking them on top of one another. When we make the rectangles thinner and thinner, the entire arrangement starts to look like a triangle. This triangle has a base equal to 2 times pi times the radius, spoken as 2 pi r, and a height equal to the radius, or simply r. Using the triangle area formula, which is 1/2 times base times height, we can find the area of this triangular arrangement. Plugging in our values, we get area equals 1/2 times 2 pi r times r. When we simplify, we're left with pi r squared. This is the area of our circle. There's another way to picture this. If we stack the annular rectangles vertically, we form a triangle in a different orientation. Here, we can take the x-axis as the radius, r, and the y-axis as the circumference of the circle, which is 2 pi r. Using the same triangle area formula, we again get the result as pi r squared. If you're familiar with calculus, there's yet another approach. By integrating the circle's circumference, which is 2 pi r, from 0 up to the radius, r, we essentially sum up the length of the circle's circumference, which is 2 pi r, from 0 up to the radius, r. We essentially sum up the lengths of all the rings from the center to the edge. This also gives us pi r squared as the total area. This idea of reimagining shapes like circles can be extended to other shapes, opening new ways to explore geometry.